Hello everybody, welcome to IB Army, and this is Jenny again. Today we are moving into the second lesson of the differentiation unit, which is the chain rule, and it's also called as composite rule. So what is the chain rule? By the formula given, chain rule is defined as dy over dx equals to dy over du times du over dx. In this case, we have two functions. The first one is the given function y. It could be defined as gu. However, in this case, u is also a function that could be defined as fx. And obviously, it's not easy to understand how this rule can be applied and why it is formed. So as usual, we are going to jump into some questions and see how it can be applied to help us. So the first question we have is to differentiate 2x plus 1 to the power of 9. Last time we had a similar question, but that was a quadratic. So we could expand it and differentiate term by term. However, to the power of 9, we're going to spend hours on it to expand it. So we are going to use this formula, this chain rule, to help us to differentiate. Pause the video and try to apply the formula and try to figure it out. So the function is 2x plus 1 to the power of 9. And with the formula, we let u equals to 2x plus 1. So y, therefore, will become u to the power of 9. And then we differentiate each of these two functions. Du over dx equals to 2. And dy over du will become 9 times u to the power of a. And then we use the formula again. Dy over dx equals to 9 times u to the power of a, which is dy over du, and times 2, which is 2u over dx. And we get the answer 18 times 2x plus 1 to the power of 8. So basically, you have to have an idea and define which function and which formula you can use for each of them. And that's how basically the composite rule works. And here we have the second one. So it's differentiate 3x squared minus 2x plus 1 in total to the power of 4. Again, use the chain rule and see how it goes. Pause the video and try it out. Again, we have to define the two functions that we are gonna differentiate. The first one is obviously the function we have, which could be defined as u equals to 3x squared minus 2x plus 1. However, the given function is to the power of 4, so y will become u to the power of 4. And we differentiate each of them. One becomes 4u to the power of 3, and the other one becomes 6x minus 2. And then we multiply them together. And the answer is 8, if you simplify it at the end. 8 times 3x minus 1 times 3x squared minus 2x plus 1. Again, you have to have an idea that there are different functions exist in the total functions, and you have to layer them out and use the formula to kind of integrate them together. And now we kind of have a little bit more difficult one, and it's find the derivative of 1 over square root of x squared plus 2x. Again, you have to differentiate and use the chain rule. Pause the video and try it out. So as we talked about in the previous lesson, don't be afraid by the square root or 1 over something. You can always express it in the way of power. So in this case, the function is actually x squared plus 2x to the power of minus half. And again, we do the same thing that we do for the previous question. We define two functions. The first one is u equals to x squared plus 2x, and it's in the bracket. So the actual function is to the power of negative half, so we define y xu to the power of negative half. And then we differentiate each of them, multiply them together in the step 4, and the answer should be negative x plus 1 times x squared plus 2x to the power of negative 3 over 2. So don't be scared by this difficult or weird notations. You can also express them in a simpler form that you can understand and use the formula. And the last one it's a challenge. Find the derivative of fx equals to e to the sine x squared. So we haven't talked about the formula of trigonometry function differentiation yet, but you have a formula in the IB math formula booklet, so you can always use it. But the trick of this one is that you don't only have two functions, you have three. So you layer them out, find the corresponding differentiation formula for each of them, and you can use the chain rule, multiply them together, and you will get the answer. Pause the video and try it out. So we can see now we are using mental math because you already get used to how you can define the functions, and you know that there are three layers. The first one is the total one, the big one, and then it's sine x squared, and then it's x squared. So what you actually differentiate at the end is 2x. So if you don't approach x at the end, that means that your differentiation hasn't finished. But then if you separate them into three layers and you differentiate each of them as I listed, you get the answer as e to the power of sine x squared times cos x squared times 2x. However, this is the more straightforward way, but you can also use the traditional method to organize your thought. So the first step, the three functions you need, v equals to x squared, which is the smallest part, and then u equals sine v, which represent x squared as v, so you can just use v in this function. And then y equals to e to the power of u, as you use u to express everything else in the function. Then you differentiate each of them, and at the end you just multiply all of them together and you get the same result. So always is the chain rule. You don't have to list out all of the functions that are included in the given function every time, but just remember that there are different layers and you have to find the different formulas and go to the end that only has the direct relationship with x, and then you're done. And that's it with the chain rule. Hope to see you next time. Bye!